So let's look at the second part. Find the position vector of P on L such that OP is perpendicular to L. Okay, great. So P, we don't know where is P. So OP is perpendicular to L. So let's say this is P here. Okay, we need to find this P here. So P is on the line equation L. So we know that for some, this is what we like for some, they use T, right? T, real value. The OP will take the line equation because it's on the line equation. It's on the line. So it will satisfy the line equation. And this would be 1, 2, 3 plus T minus 1, 1, 1. Okay? Now, what I need to understand is this. This line equation here. This is like an address bar. So basically, you want to find the specific address, which is the T, which corresponds to P. Okay, that's about it. And because OP is perpendicular to the line, so we know that hence OP dot with D will be 0. And this will just give us 1, 2, 3 plus T minus 1, 1, 1 dot with minus 1, 1, 1 will be 0. And this case here will be minus 1 plus 2 plus 3 plus T 1 plus 1 plus 1. Okay, we dot them, it will be this. So this is 3T 5 minus, so it's 4 plus, so T equals to negative 4 over 3. Okay, that's it. So you get T equals to negative 4 over 3, and we're just going to substitute it into the equation for OP. So OP, hence OP would just be 1, 2, 3 minus 4 over 3 negative 1, 1, negative 1, 1. So there you go. In calculator, 1 plus 4 over 3 will just be 7 over 3. 2 minus 4 over 3 will be 2/3. 3 minus 4 over 3 will be 5 over 3. Okay. So this is how I do this question here proficiently.